I want to show you how to do some what's called implicit differentiation, which comes up quite a bit. And if you don't understand how to do it, it's really a pain. If you don't understand what you're doing, it's going to be a real pain when you get to calculus 3. So I want to look at this problem right here. So pause the video and read that problem real quick and then come back. So what you're looking at here is this ellipse here. It's a rotated ellipse. And what it wants to do is find the point at which the ellipse crosses the x-axis and what the slope of the tangent line is there. Find the equation of the tangent line maybe. And so you're going to look at it's crossing there and it's crossing here. All right. So you want to find the equation of the tangent lines there. If you look at the function though, you can't solve for y. It would be very hard to solve for y in terms of x, y in terms of x, some function of x. You could use the quadratic formula, but it would be a really nasty looking formula. So the better way to do this is to say, okay, y is an implied, so it's implied, you can say it like this, it's implied that y is a function of x. It's implicit that it's implicit or it's implied that y is a function of x. Y is some function of x. But still, I want to find dy dx. Or if you want to write it like this, y prime of x. Once we find y prime of x, I can get the slope of these tangent lines, and I can find the equation of the tangent lines, okay? So let's start this out. So one thing you need to know before you start implicit differentiation is the chain rule, and you understand how the chain rule works. So know the chain rule, and if you don't, there's a video on it. So I'm going to go over one little thing real quick. If you have f, suppose that f of y is let's say it's y squared, and g of, no, what I want is y of x is, let's say that's 3x minus 1. Then f of x will be 3x minus 1 quantity squared. And now when you find the derivative of f with respect to x, you get 2 times 3x minus 1 times the 3 inside, right? So 6 times 3x minus 1. Derivative of the outside times the derivative of the inside, like that. Now, what if you didn't have this, but you still wanted to find it? So the chain rule works like the following way. So if I want to find df dx, so the derivative of f with respect to x, the original chain rule works like this. It's df dy times dy dx. That's actually what's going on here where I took the derivative. That's actually what's going on there. So how does this work? So if you look at the original here, df dy is 2y, and then dy dx was 3 times 3. So what you get is 6y, and then y was 3x minus 1, so it'd be 6 times 3x minus 1. And that's what we got to begin with. So what we did was we used the general chain rule there and in that sense, but in this instance we used the actual definition of the chain rule. Now, if you have something like the following equation, like we had before, x squared minus xy plus y squared equals 3, and it's very difficult to solve for y, but you still want to find dy dx. So what is dy dx? So what we're going to do is we're going to take the derivative with respect to x on both sides. And so we're going to apply that to every single term. And then wherever there's a y term, we're going to use the chain rule. So before I start this, I want to look at this y squared here. So if you have y squared, then the derivative with respect to x of y squared, this is a function itself. So I'm going to take the derivative of y squared with respect to y, and then dy dx, like that. So this becomes 2y times dy dx. Now I don't know what dy dx is. We're figuring that out. So we're going to hold on to it. All right, now I want to look at that middle term now. Let's look at this one. And I'm not going to pull the negative down with it. So we're going to do d dx of xy. So this is the product rule. So this is f and g, right? So f prime will be 1 times. So remember the product rule, when you take the product rule, this is f prime, let me make this bigger, g plus f g prime. Some people write f g prime plus f prime g, but I don't like to do it that way. And I think I'll put that in a video that I've done. Anyway, so it's f prime, which is 1. Now g is y plus f, which is x, and then g prime. So g prime, this would be dy, the derivative of y with respect to y times dy dx. This is the chain rule. Now, it would normally be written df dy dy dx. But I don't need the f in there. I'm just going to use what's there, the actual function y. Well, dy is 1, so this piece here is 1, and then I just write dy dx, so it's times 1 dy dx. And so what we get out of this is y plus x dy dx. So that's that middle term there, and then the rest of it will be easy. So let's move on. So let's do it. So we're going to take the derivative with respect to x. For every term, we get 2x minus, remember there's a minus out front, and then I'm going to rewrite this. So minus y minus x dy dx, and distribute the negative. And then plus, now y squared, the derivative of that is 2y dy dx. 2y dy dx. And then the derivative of a 3 is just 0. All right, so this is what I get so far, and now I just move the dy dx terms to one side, let's move the 2x minus y, let's move that over to the other side. So I get negative x dy dx plus 2y dy dx equals negative 2x plus y. Now I'm going to multiply through by a negative, and I'm also going to, well, no, I don't need to. So let me pull out the dy dx, and I get negative x plus 2y equals negative 2x plus y. So I get dy dx is negative 2x plus y over negative x plus 2y. And let's clean this up a bit. This would be y minus 2x over 2y minus x. So that is the derivative of y with respect to x. And there you have it. And there's no complicated formula. We could, technically, like I said before, we could take this and use the quadratic formula to solve for y, but there's really no need if we know implicit differentiation pretty well. So there's my derivative of y with respect to x, and then for any point on that ellipse, I can find the slope of the tangent line. All right. So for example, dy dx. Let's say x was let's say x is 0. So where's my graph? Here it is. So when x is 0, yeah, that's where it hits the y-axis. All right. So when x is 0, you get plug in 0 there. You get y squared equals 3, which is y equals plus or minus root 3, or it's about 1.732, and that looks like about 1.7 right there. So when x is 0 and y is root 3, plus or minus, let's say root 3, so dy dx of 0 comma root 3, that's that top point. You're just going to plug in 0 for x and root 3 for y. So root 3 minus 2 times 0 over 2 root 3 minus 0 becomes root 3 over 2 root 3, which is 1/2. So that's the derivative there. So what that tells me then is this graph right here, the slope of that tangent line is 1/2. And it should be the same here as well. It will be. All right, so that's that problem. Now, it does get more complicated. So let's do another example. Let me pull one of these over. What looks good? Let's do this one, number 8. All right, I'm going to pull 8 over, pause the video, and we'll start it. All right, so what I've done is I've gone ahead and brought this problem over, and then I want to graph it, and this is what the graph looks like. So let's go ahead and find dy dx. So I'm going to find d dx of both sides. 2x plus 2x cubed plus x squared y minus xy cubed equals 2. All right, so we're going to apply that to every single term. All right, so what I'm going to do is I'm going to call each of these different letters. I'm going to call this one capital A, this one capital B, this one capital C. The derivative of 2 at the other side is just going to be 0. So for A, what we have is we have 2x cubed. And when I take the derivative with respect to x of 2x cubed, that's simple. That's just 6x squared. For B, I'm going to take the derivative with respect to x of x squared y. So we're going to use f times g. When you take the derivative, you get f prime g plus f g prime. So the x squared is going to be the f, and the y is going to be the g. So this becomes 2x times y, that's this and this, plus x squared. Now, dy over dy, so it's derivative of y with respect to y times dy dx. We are using the chain rule here. It's a chain rule because y is some function of x. I don't know what it is. And f, if you want f, is just pretty much y. So df dx is the derivative of f with respect to y times the derivative of y with respect to x. F in this case is just good old y, so it's just dy over dy dx. Okay, if this introduction of f confuses you, just don't worry about it. Don't look at it. If this is working for you, great. So then this just becomes 1. This here is 1. So we get 2xy plus x squared dy dx. And now let's look at c. So c is xy cubed. So I'm going to take the derivative with respect to x of that. Derivative with respect to x of xy cubed. So this is going to be, once again, this is f, and that y cubed is g. So f prime g plus f g prime. F prime is just derivative of x. With respect to x, it's just 1 times y cubed. Plus f is x. Now g prime, so that'll be derivative of y cubed over, with derivative of y cubed with respect to y, times dy dx. Chain rule. Let me separate these out. Well, the derivative of y with respect to y, derivative of y cubed with respect to y is 3y squared. So this becomes y cubed plus x times 3y squared dy dx. Just comes over. So then we've cleaned this up. This becomes y cubed plus 3xy squared dy dx. Now, let me put all this together. I'm going to put this and this and all of this together. So let's do that. So we get 6x squared plus 2xy plus x squared dy dx plus, there's minus, there was a minus in the original minus, right? So minus, so we go minus, and it's all this up here, minus y cubed minus 3xy squared dy dx equals 0. The reason it's 0 is because the derivative of 2 with respect to x is 0. It's just a constant. All right, so I have this. So what I'm going to do is I'm going to pause the video. I'm going to work this out, and then you can look at my work. Okay, so that's the answer right there. All right, so there's other things also, like having to do with sine and cosine, that tend to be difficult as well. Let's pull this one over. This one, e to the y cosine x equals 1 plus sine of xy, e to the y cosine x. So I want to find dy dx. So it's implied that y is a function of x. So y is some function of x. You don't know what it is. It's just implied, all right? We can't solve for y. There's no way we would be able to solve for y in this equation. So we still want to find dy dx. So we do d dx of both sides, okay? I'm not going to rewrite it all. So I want to do that for each term. So I'm going to take this one here. So d dx of e to the y cosine x. This would be, okay, here's f and here's g. So f prime g plus f g prime. F prime will be e to the y and then dy dx. So what's happening here is the following. It'll be the derivative of e to the y with respect to y times dy dx times cosine x. This here is f prime. This here is g. Then I add, and then it's going to be f g prime. F is just e to the y, and g prime would be negative sine of x. So let's clean this up. So it looks like e to the y, the derivative of e to the y with respect to y is e to the y. So it's e to the y dy dx times cosine x minus e to the y sine of x. All right, we can pull out an e to the y, but I'm not worried about it right now. In fact, we shouldn't. So then the derivative of 1, when we look at the derivative of 1, that's just going to be 0. And then the derivative of sine of xy. Let's pull this down and take the derivative of that. So I'm doing each part separately. So derivative with respect to x of sine of xy. So this is going according to the chain rule. So the sine of u, when you take its derivative, will be u prime cosine of u. It's chain rule. So this would be the derivative, so it'll be u prime, so that'll be xy prime cosine of xy. That prime means derivative with respect to x. All right, now we have to take care of that. So it'll be f prime g plus f g prime. X is the f, y is the g. So f prime will be, derivative of x is 1 times g would be y plus f is x, g prime. G prime, that will be dy, the derivative of y with respect to y. It's just plain old y. So that'll be times 1. So this will be y plus x. All right, so now we got that piece, and then we have this piece on the left. And so let's put all this together. Oh, that's y plus x. So wait, that was this over here. So that will be, this gives us, yeah, times cosine of xy. So this will be y plus x times cosine of xy. So when we put all this together, we get, pull this up, e to the y cosine x dy dx minus e to the y sine of x equals y plus x times cosine of xy. And now, oh, I'm missing a dy dx in here somewhere. Where'd it go? Where'd it go? Where'd it go? It's this right here. It's dy dx goes here. Yes. When I took the derivative of y with respect to x, I get dy dy, derivative of y with respect to y, and then dy dx. Ah, so that goes there. So let's tack that guy in there. So this becomes dy dx here. And times cosine of xy. So now what I should probably do is multiply that through. So this becomes y cosine of xy plus x cosine of xy, x cosine of xy, that's times dy dx. All right, so let me pull that up and put it where it needs to be, right here. So it's y cosine of xy plus x cosine of xy, and then dy dx at the end. Now, the key here is not to get too lost in this. It's probably too late for that. I've got my dy dx term here and a dy dx term here, this very first one here. So I'm going to put those together. Let me pull this one to the right, and let me pull this one to the left. You get your dy dx terms on one side. Now let me do it the other way around. I'm gonna keep my dy dx on the left. So I'm going to pull this one over, and I'm going to pull this one over. So when I do that, I get, let me do it in blue. I get e to the y cosine x dy dx. That's from here. And then I pulled this one over, so that's minus x cosine of xy dy dx equals, now I've got to deal with this one. So then it's y cosine of xy plus e to the y sine of x. If this is right at the end, it's a miracle. And then, so let's see what happens. I'm going to erase all this. I'm done with that. So now I'm going to take out the dy dx, so dy dx, and I get e to the y cosine x minus x cosine of xy equals y cosine of xy plus e to the y sine of x. Right, yes. So then I'm going to divide by this piece, and so I get dy dx is equal to y cosine of xy. I'm writing what's on the right, plus e to the y sine of x over e to the y cosine of x minus x cosine of xy. And there you have it. So the question on my tests might be more like find dy dx when x is pi over 2 and y is 1 or something like that. And then you would plug in pi over 2 for x and then y is 1. I don't know if this is even a point on the graph, but let's just suppose it is. You just plug in pi over 2 for all the x's, 1 for all the y's, and then you get your slope. And there you have it. So that's the first part of implicit differentiation.